Oh, I don't know why you did that, but
So now we're doing logarithms.
Is this hard?
No, it's not hard.
Isn't that pretty much?
Okay, if we have a question like a to the power of x equals y, we're given the a and we're given the y, those are numbers, x is our unknown number, then what you can kind of think, like, you know how you normally rearrange an equation, like you take numbers over and divide, or take numbers over and add and subtract, stuff like that. You can kind of think of doing that. So what we're going to do is like take this a over and it becomes log of base a. So what, well, x stays there. So you end up with x on that side and you get log base a of y. So you can kind of think if you're taking over, if you have an unknown power, you take over that base, and the opposite of that is log. Yeah, so if you have log a y equals x, then it works the other way. So you take the log over, and that becomes the base of a power. So you get y equals, take that over, becomes a to the x.
Why then I that's not
Sorry, that's an a. So for example, if we have log base 2 of 32, we want to find that what that equals. So we'd say that equals x. Solve what x equals. We take the log 2 over. The 2 becomes the base, and we raise the power of x up. So we get 32 equals 2 is our power, and we raise up the x.
And then we just do this stuff.
Yeah, pretty much. Yeah, so from there, 32 is 2 to the power of 5. And so x equals 5.
Miss, where did the x come from?
It's wanting us to solve log base 2 of 32, so we just call that equation x, or that expression x, just so we have something to rearrange. So another one, for example. Log base 3 of 81. Or another way to say it is log of 81 to the base 3. Yeah, so we call that equals x, right? We take this log 3 over, and that 3 becomes the base, and we raise up our x. So then 81 is 3, 9, 27, 81, so 3 to the 4, and therefore x equals 4.
You don't need a calculator to do this at all.
No.
I thought you did.
No.
Yeah, well, it sounds like something to calculate. Yeah, I thought.
Sometimes it's not as easy, because you sometimes won't get a nice number like 81 where you can make it 3 to the 4. Yeah. What if it was 82? Like, it's not as easy. You wouldn't get a question like that. Okay, we've got some log laws.
Are we going to assume that every number that they give us is going to be some sort of square root?
On the test, yeah.
So we're going to need any decimals?
No. Well, the final one might be a decimal after you like rearrange, but you should be able to like change every large number into a simple base in power. Okay, our log laws are, if we have log base a of m times n, that's the same as log base a of m plus log base a of n. Works back the same way as well. If you start with this, you can simplify it into the first one. Rule number 2, if we have log base a of m divided by n, then it's a minus, the numerator minus the denominator. rule 3 is 1 over n, and that's negative log a to the n. Rule 3 is actually rule 2, just where m equals 1.
No other number, miss?
Sorry?
Like, can there be like 2 on n?
Well, 2 on n would be m on n. So 2 would be m, and you'd have a number for your n. This is in these rules, a, m, and n are numbers. They're not letters. And rule 4 is log base a of m to the power of p equals p times log base a of m.
Okay.
Right, examples. Log base 5 of x equals 3. We take our log over, 5 becomes the base, raise up your 3. So we're left with x on this side, 5 becomes the base, we raise up our 3. 5 to the 3 is 125. Done. Next one, log base 5, 2x plus 1 equals 2. Okay, so we take our log 5 over, so we're left with 2x plus 1 on that side, 5 becomes our base, raise up your 2. So then 2x plus 1 equals 25. Take away your 1, 24, divide by 2. Oh.
So you raise one of the numbers on the other side of the equation?
Yeah, so log is like the opposite. You know how like times is the opposite of divide, plus is the opposite of minus? Log is like the opposite of a base to a power.
Also,
So like the little number with your log, your base of your log is the base of the power when you take it over. It's like that little 5, when you take the log over, becomes base 5, and then whatever's on this side, you raise that up. Yeah. Okay, next one, we've got log base 2 of 2x plus 1 minus log base 2 of x minus 1 equals 4. Which rule will this use? Log minus log.
Oh, the second one.
Yeah, rule 2. So we can actually change it into log base 2 of the first one divided by the second one. So 2x plus 1 over x minus 1. Equals 4. Right, our log 2, take it over. Your base is 2, raise the 4 up. And then from there, all you got to do is a bit of rearranging to solve for x, just how you normally would. So it's 2 to the 4. Yeah. Going to take the x minus 1 and multiply it over. Expand out that bracket. 16x minus 16. Right, I'm going to take my 2x over, so I get 14x on this side. I have 1 plus 16, so I get 17 on that side. And just divide by 14. 17 on 14. We all followed along with that one?
Yeah.
Good. Let's try another. They're all on the sheet, so if you missed it, just check the sheet. Okay, log base 3 of x minus 1 plus log base 3 of x plus 1 equals 1. What rule? 1. So we can actually make it log base 3 of x minus 1 times x plus 1. Be careful in your rules, the log bases have to be the same. So you see we've got that base 3 and base 3. That means that we can use the rule. Then you can't use the rule.
What would you do?
You won't be able to do it.
So will there be anything that we'll have to
No.
get the log into the same
No.
base? So could it be like log 3 and plus log?
You'd only see questions like this where you can use the rule. Yeah. Okay, so the rule is log base 3 and you multiply the two brackets. Technically should be like that, I think. Okay, so take our log over. The 3 becomes the base, and we raise the 1 up. Of course, doesn't make much difference. 3 to the 1 is 3. And then all you have to do is solve for x. So x squared minus x plus x is 0 minus 1 equals 3. X squared minus 4 equals 0. X squared equals 4. X equals plus or minus 2.
Too easy.
Pretty much.
Why is it plus or minus, miss? Is it just
Square root of 4 can be plus 2 or minus 2. Alright, last one. 2 log base 2 of 4. What rule? Fourth one. So we can actually do 4 to the power of 2. Right, this is, did I say it the wrong way? P log A M. So we can make it log M to the P to be 4 to the 2. So log 2 4 squared.
Does that equal 0?
No, it doesn't equal anything. What we're trying to find is what it equals. So we could just say equals x. So that we have something to rearrange. So take that over. We get 4 to the 2 equals 2 to the x. Change the 4 into a base of 2. So it'll be 2 squared squared equals 2 to the x, which is obviously 2 to the 4 equals 2 to the x, so x equals 4. Everyone good? Wonderful.